In this video, we're going to look at problem number 2 on our review for the end of unit assessment for Unit B. In number 2, at the very top, we start with a given equation and an R value. This is the information that we would find if we used a Desmos calculator, but it's given to us, so we don't actually have to do anything here in terms of entering this into the computer. No. Everything we need is right here on this paper to answer these questions underneath. What we want to do here is we want to recognize what we have. We have the weight here, that's on our y-axis, and we have the kilometers run per week, that is on our x-axis. So here, we looked at the running habits of 15 people and compared that to their weight. The distance in kilometers each person won is graphed with their weight in this scatter plot. And we're going to select all the statements that are true. So statement A is about the y-intercept. So the y-intercept is going to be where we cross the y-axis. The x-intercept would be where you cross the x-axis. So A here is saying that it's talking about the y-intercept, which would be this one. So let's see what they say. If the linear trend holds, the weight of a person would be 0 kilograms for a person who runs about 10 kilometers each week. So 0 kilograms, 10 kilometers. Where is that on the graph? Well, here's our weight. It would be 0 when we run 10 kilometers. That's here. Now, what do you think? Is A true or is A false? A would be false because this is the x-intercept. And this says y-intercept. So this statement is not true. For B, we're looking at the value of the correlation coefficient. It's very close to -1, so there is association. For this one, in B, you want to take a look at your notes for everything that you know about correlation coefficient. Correlation coefficient is a number that goes between -1 and +1. We call it our R. So R can equal -1, 0, or 1. And there's a group of words that go together for each one of these that help us understand what the correlation coefficient means. If the correlation coefficient is close to -1, we have a good line. We can make strong predictions. And there is association in our numbers. If our number is close to 1, we also have a good line with strong predictions, and there is association. It's just the slope of the line is positive or the slope of the line is negative. If the correlation coefficient is 0, it means we have a bad line. There is no good line to represent this type of data. So we say it has weak predictions and no association. Looking at these three groups here, we can determine if B is true or false. Very close to -1 is association. Well, sure enough, in my notes, there is association when it's close to -1. So this statement is true. I can circle it. In C, every person who runs 3 kilometers per week weighs less than a person who runs 2 kilometers per week. Well, let's look at 3 kilometers. 3 kilometers is right here. We're looking at, this person and this person. And we're looking at comparing that to people who run 2 kilometers, which is this one and this one. Oh, these two here are lower than these. So most of the time, the trend goes down. But here, these two people run 2 kilometers and they weigh less than these two people. The problem here is that it says every. Every is going to tell us here that it's certain, always. No, it's mostly. Mostly it's going down, not every. So this statement here is false. For D, the weight of a person tends to decrease the more kilometers they run per week. So this graph, does it decrease or does it increase? Well, decrease means it's going down, increase means it's going up, so this graph is decreasing. The weight of a person tends to decrease. I would say that is true. The last one for us here is about the slope. The slope indicates that the weight of a person who runs 5 kilometers per week is 0.559 kilograms less than a person who runs 4 kilometers per week. So really this sentence is asking us, is the slope negative 0.599? Well, when our equation looks like y equals mx plus b, we know the slope is the number in the place for m and the y-intercept is the number in the place for b. So in this equation, y equals mx plus b at the top of the page, here we have m, the first number, connected to the x, negative 0.559. So yes, the slope is, in this instance, negative 0.559. You might try to look at that and find the answer from the picture here by looking at 5 and looking at 4 and trying to see how far down does this go. Well, we go from like 86 down to 85.5, so we go down 0.5-ish in the one here. Oh, and that's about this here. So it does work this way, but it's much easier if you notice that you have the answer right here.